This video is designed to show you how to use Excel to get the optimal portfolio weight. Our objective function is this one here. It is the sum of expected portfolio return minus the portfolio variance. Alternative objective function is so-called the minimum variance portfolio. We just need to minimize the portfolio variance. So I will show you how to use Excel to achieve these two different objectives. So these are two different objective functions. This one is maximize expected portfolio return, give a penalty on the variance. The second one, just minimum variance returns. So to do this, we need to calculate W, we need to have expected returns, we need to have omega, which is the covariance of the assets. So I will show you step by step how to calculate expected return and how to calculate the variance covariance matrix. The starting point is our data. I have here data of 4 assets, 3 stocks and 1 ordinary. I calculate the returns. Now, if I want to calculate the expected return, as we learned in statistics, we always use sample average to estimate the population mean. And in this project, I use the data up to 2022 for construction of portfolio, the rest for comparison. So in your project, you will need to determine your time span for analysis and your time span for comparison. So first the 5 year for the calculation and last 1 year for the comparison. Here, my calculation time period is all marked in yellow. So I have average from G3 to G46. This is wrong, should be 45. Because I only want to use up to 2022. So I calculate this. So this is my sample average returns. Yeah. Now, the next step is to calculate the covariance of the returns. How do we do that? So click on data, go to data analysis, choose covariance, click OK. Then he asks me to give the data range. So input data range are these 4 columns. So because I calculate covariance for 4 assets. So when I click OK, then this is covariance matrix. Excel output a lower triangular because this is a symmetrical matrix. And we need to use a symmetrical matrix not only in the lower triangular part. So how do? I show you here. I copy these and paste it special, and I choose values, skip blank, and I click OK. I have the lower triangular. And then I highlight this again, click copy, and this time I paste the special values, skip blank, and transpose. So this is a 4x4 covariance matrix, omega. Now I have omega. I will need to have my R bar, which is the expected returns. And my expected return, I have calculated previously here. Remember, I did this calculation. This is my expected return. So I will need to put it here, expected returns. So I need to paste actually the values, not the formula. So choose value, I get this. And what I need now in the formula, so these are the two formulas. I copy the formula to our worksheet. So what do I need? I need W. So W will be the portfolio weight. So this serves tentatively the value of the portfolio weight. It serves also as the initial value of the optimization numerical procedure. So you can choose any numbers here. In my case, I choose 0.25 because 4 of these add up to 1. And then I need to calculate the W plan expected return. This is the portfolio returns. Portfolio returns, how do I calculate? So I use the function matrix multiply in Excel. So I have here X R bar times W, and then this will be my expected portfolio return. The next, I need to calculate W plus omega W. Unfortunately, in Excel, I can't do it in one step. I need to separate these in 2 steps because Excel accepts the matrix multiplication only with 2 factors. So the first will be W plan. W plan is transpose W. So I have here transpose W. The second is omega. Omega I have here, omega. And then bracket. So I have transpose, I here mistype, transpose. Yeah. So you see here, W plan omega, W plan is 1/4, omega is 4/4. The product is still a 1/4 vector. And now I can calculate W plan omega W. So this will be these 4, again, matrix multiplication, these 4 numbers with W. So now I have all the things I need. I need to have my objective function. So my objective function is expected returns, expected portfolio return, this term, yeah, W plan R bar minus alpha W plan omega W. So I choose alpha to be 1. So I have here. So I want to maximize this term marked in yellow by changing the components of W subject to the restriction. They must add up to 1, and each weight must be positive. So how can I do this? You click on Data, and here is a solver. Click on Solver, and then Objective. What is our objective? It's this one. Objective is this one, AB2. And we want to optimize, maximize this by changing what? Changing these 4. So, and now we need to add restrictions. So click on Add. First, I want these 4 to be non-negative. So greater or equal to 0. Second, I want to have the sum of these 4 to be exactly 1. When I click OK, you can see this is the pop-up of the solver. So what does it solve? It solves the maximization problem of the objective, this one, by changing these 4 cells, Q2 to Q5, with restriction Q2 to Q5 non-negative and add up to 1. So when I click Solve, it is done. You can see here. This is the solution. So it asks me if you want to keep the solution. I say okay. Then this is the optimal portfolio weight for the 4 assets. For the 4 assets. Yeah. So now we may want to have another or alternative object. So the alternative object is minimum variance portfolio. So minimum variance portfolio differs from this objective in that we only want to minimize the variance of the portfolio. So how can we do this? This is easily done if you click on Solver, and then we need to change our objective to covariance matrix or variance of the portfolio. This is W plan omega W. This is our objective. And this objective Z2 should be minimized, not maximized, by changing the cell Q2 to Q5 under the same constraint. If I click Solve, then you see here the weight changes. So this is the solution to minimum variance portfolio. That's it.